Let's solve the following system of linear inequality. So here we are given two inequalities. The first one being absolute value of x minus 1 is less than equals to 5. And the second inequality is that absolute value of x is greater than or equals to 2. We'll begin with the first one. So here we have x minus 1. So this is less than or equals to 5. Now we can use a property of inequality. That means if we have absolute value of x less than a number, let's say a, then we can also express this as x lying between negative a and positive a. So using this property, we can rewrite our given linear inequality as x minus 1 lying between negative 5 and positive 5. Now what we'll do, we'll add throughout with positive 1. So we have negative 5 plus 5 less than or equals to x minus 1 plus 1 less than or equals to 5 plus 1. So negative 5 plus 1 will be negative 4 less than or equals to x less than or equals to 6. So this is our solution to our first linear inequality. So we'll keep it aside. Let's label this as number 1. In the second linear inequality, we have absolute value of x is greater than 2. So here we can have two cases. The case number 1 being when x is a positive number. If x is a positive number, then we can say that absolute value of x will be equals to x, such that the inequality will now become x greater than 2. And in case number 2, if x is a negative number, then in that case, absolute value of x will be equals to negative x, such that negative x becomes greater than or equals to 2. Now what we can do, we can multiply both sides with negative 1. But in doing so, the sign of the inequality changes, so it will become less than or equals to negative 1 times 2 is negative 2. So this is the solution to, these are the two solutions. We'll call it 2.1 and 2.2. Now let's find a common solution. That means combine 2.1 and 2.2 to get a single solution. So here we will sketch a number line. On the number line, here, this is greater than or equals to 2. On the number line, we'll take negative 2 and positive 2. So the 2.1 states that x must be greater than or equals to 2. So we'll consider all the values of x which is greater than or equals to 2. And x less than or equals to negative 2 means we'll consider all the values of x which is less than or equals to negative 2. So this is the region. So it will take all the values which is lying to the left of x equals to negative 2. Here negative 2 is also a part of the solution and x equals to 2 is also a part of the solution. Now we will combine the two solutions and we'll find a common solution which satisfies both 1 and 2.1 and 2.2. So let's do that. So for this, we are going to consider a big number line. So here we will consider negative 4, negative 2, positive 2 and 6. So from number 1, we have x lying between negative 4 and positive 6. So this is the region. So we have all the values of x lying between negative 4 and positive 6. Fine. Then from number 2.1, we have all the values of x which is greater than or equals to 2. So this is the value, all the values of x which is greater than 2. And then we have x less than or equals to minus 2. That means we'll consider all the values of x which is less than negative 2. So what we'll do, we'll have to find a common solution, a common region. So this is one common region and this is another common region. So this is going to be the solution or the value of x which satisfies both the two inequalities. So that means we will have x belonging to the interval negative 4 to negative 2 union positive 2 to 6. So this is the solution that satisfies both the two linear inequalities.